The question is, what would happen if all the world's nuclear bombs were detonated simultaneously on the surface of the Earth? Let's imagine a little based on real data. There are now more than 12,500 artificial suns sleeping on the surface of the Earth. They are silent but alert, deployed on the tips of missiles, deep inside submarines, and in the bellies of bombers. According to a 2025 report by the Stockholm International Peace Research Institute, SIPRI, the total number of nuclear warheads in the world is now 12,241. Of these, about 9,614 are kept in military stockpiles ready for immediate use. And the most frightening information is that about 2,100 of these warheads are kept on high operational alert. That is, they are ready to be launched at any moment. US President Donald Trump himself once said, "We have nuclear weapons that can destroy the Earth 50, 100 times over." This is not an exaggeration. This is reality. Today, we will learn what would happen if all these weapons were to explode together on Earth. This is not a movie story. It is a realistic picture based on hundreds of scientific studies, computer simulations, and the irrefutable laws of physics. Let's look at the catastrophic consequences step by step in time. Step 1. The first second. The birth of the fireball. Suppose all 12,241 warheads on Earth were gathered in the same place and detonated simultaneously. The total yield of this explosion would be approximately several thousand megatons. For comparison, remember that the yield of the little boy bomb dropped on Hiroshima was only 15 kilotons, 0.015 megatons, which is equivalent to 15,000 tons of TNT. And today's modern B-83 bomb has a maximum yield of 1.2 megatons, that is, 80 times more powerful than Hiroshima. The yield of the W-87 warhead is 300 kilotons, which can be increased to 475 kilotons if necessary. Now, in this huge explosion of thousands of megatons, a fireball will first be created. Its diameter can be determined by a scaling formula. R is proportional to W to the power of 0 times 4, where R is the radius of the fireball and W is the yield of the explosion. According to this formula, an explosion with a yield of 10,000 megatons will have a diameter of more than 50 kilometers. The temperature at the center of this fireball will reach 50 to 150 million Kelvin, which is several times higher than the temperature at the center of the sun. No matter can survive at such temperatures. Soil, rock, steel, everything will instantly turn into plasma. Here, the Stefan-Boltzmann Law of physics comes into play. P is proportional to T to the power of 4, where P is the radiated heat energy and T is the absolute temperature in Kelvin. Even with a slight increase in temperature, the rate of thermal radiation increases to the 4th power. When the temperature reaches 100 million Kelvin, the thermal radiation emitted will be so intense that people hundreds of kilometers away from the fireball will instantly receive third-degree burns. Those who look directly at the explosion's light will be permanently blinded by the permanent burning of their retinas. The energy released in this first moment can be explained by Einstein's mass energy equation, E equals mc squared. In a nuclear reaction, a small amount of mass is completely converted into energy. In a 1 megaton explosion, about 0.046 grams of mass is converted into energy, which is equal to 4.184 times 10 to the 15th power joules of energy. Now imagine how much mass would be converted into energy in an explosion of thousands of megatons, and how much energy would be released. Step 2. The first 30 seconds. The onslaught of the shock wave. Immediately after the fireball expands, a terrible shock wave or shock wave will be created. This wave will spread around many times faster than sound. The physics of the shock wave can be explained by the Rankine-Hugoniot equation, which expresses the conservation of mass, momentum, and energy on both sides of the shock front. The air pressure over a large area from the explosion site will increase many times more than normal. This excess pressure is called overpressure. 20 pounds per square inch of overpressure is enough to crush any concrete building like a house of cards. All infrastructure within an area of about 232,000 square kilometers from the explosion site will be destroyed. This shockwave will be followed by a suction effect, that is, a vacuum effect. After the air is pushed outward by the enormous pressure of the explosion, air will rush in from the opposite direction toward the center. Structures that survive the first impact will completely collapse in the second impact. The earthquake caused by this huge explosion will be unprecedented. The soil at the explosion site will melt and create a huge cavity. Nuclear cratering studies have shown that this hole will be several kilometers in diameter and several hundred meters deep. Step 3. The first few minutes. Electromagnetic pulse and the death of civilization. An electromagnetic pulse, EMP, will be created immediately after the explosion. The Compton Effect is responsible for this phenomenon. When high-energy gamma rays from a nuclear explosion collide with molecules in the atmosphere, electrons are ejected, and a massive electromagnetic wave propagates at the speed of light. In this process of Compton scattering, the electrons gain enormous kinetic energy, and these accelerated charged particles emit electromagnetic radiation. According to Maxwell's equations, the movement of these Compton electrons creates powerful electric and magnetic fields. Studies have shown that even a single nuclear explosion at high altitude can produce electric fields of up to 50 kilovolts per meter. This wave is capable of instantly burning out all electronic circuits in its path. If 12,500 warheads were to explode simultaneously, the entire world's power system, communication networks, the internet, transportation systems, banking and financial transactions, food and water supplies, every artery of modern civilization would be shut down in an instant. Everything from hospital life support systems to water treatment plants will grind to a halt. The few people who survive the initial explosion will find themselves in a dark, silent, and completely immobile world. Step 4. The first hours. Firestorms and poison in the sky. Even more devastating than the shock wave will be the firestorm. The thermal radiation will instantly ignite anything that can burn over a wide area. Plants, wooden buildings, plastic, oil, all of which will catch fire. These fires will coalesce to form a giant firestorm that will suck out all the oxygen in its vicinity. The temperature at the center of the firestorm will be so high that even glass will melt. The smoke and particles produced by these fires, what scientists call soot or black carbon, will rise into the sky, passing through the troposphere and directly into the stratosphere. According to the latest research from Penn State University, in a full-scale global nuclear war, about 150 teragrams, 150 million metric tons, of soot would enter the stratosphere. For comparison, a regional nuclear war would release about 5 teragrams of soot, enough to reduce global corn production by 7%. 150 teragrams of soot would be 30 times more damaging. Even more alarming, the fires would release chlorine and bromine compounds, which are extremely harmful to the stratospheric ozone layer. These particles would be the biggest factor in determining the fate of humanity. Step 5. The first few weeks. The arrival of nuclear winter. Now comes the terrifying chapter called Nuclear Winter. The 150 teragrams of soot deposited in the stratosphere would block sunlight from reaching the Earth. These soot particles absorb and scatter solar radiation, greatly reducing the amount of sunlight reaching the Earth's surface. A team of researchers at Penn State University recently simulated the effects of a nuclear winter on crop production at 38,572 locations around the world, using the Cycles agroecosystem model. Their study found that 150 teragrams of soot emissions could lower global temperatures by more than 8 Kelvin, about 8 degrees Celsius. And the scariest thing is that in some regions, particularly in major food-producing areas of Europe, China, and North America, temperatures would drop below freezing and remain there for years. It's not just a winter, it's a new ice age. And this could last not just a few years, but more than a decade. The study found that it would take 7 to 12 years for crop production to recover. Another shocking fact, The study found that even if just 2% of nuclear weapons were detonated over cities, ice age temperatures would be reached, and more than 2 billion people would starve to death within the next 2 years. We're talking about 100% weapons here. It is easy to imagine how terrible the consequences will be. Step 6. Ozone depletion, when the sun becomes the enemy. But that's not all. The fireball from a nuclear explosion creates nitrogen oxides in the stratosphere, which act as a catalyst for the destruction of ozone. In addition, soot particles deposited in the stratosphere absorb solar radiation and heat the atmosphere, which accelerates chemical reactions and further accelerates the process of ozone destruction. The fireball from a nuclear explosion creates nitrogen oxides in the stratosphere. The presence of nitrogen oxides and the heat absorption by the soot can cause rapid ozone depletion, which will increase the level of UVB radiation at the surface. Studies have shown that a full-scale nuclear war could destroy up to 75% of the ozone layer, and this condition would persist for 15 years. The ozone layer in the tropics will be damaged by 65%. What does this mean? The ozone layer protects the Earth from the sun's harmful ultraviolet rays, UVB. If 75% of the ozone is destroyed, the level of UVB radiation at the surface will reach a level where the UV index will be more than 35 for 4 consecutive years. And during the Southern Hemisphere summer, this index will be more than 45 for 3 consecutive years. Incidentally, a UV index of more than 11 is marked as extreme or extremely dangerous. This level of UV radiation is capable of not only causing skin cancer, but also directly damaging DNA. Any living creature that stands in sunlight for a few minutes will start to mutate its cells. Plants that have somehow survived the cold and darkness will also die from this UV radiation. UVB radiation disrupts the photosynthesis process of plants, damages DNA, and causes oxidative stress, which will further reduce crop production. A Penn State University study found that UVB damage would peak 6 to 8 years after the war and would result in a further 7% reduction in crop yields. That is, the 80% reduction in corn yields already caused by 150 teragrams of soot would be reduced by another 7% due to UVB, for a total of 87%. The Earth's atmosphere would become a toxic, unshielded chamber where the sun itself would become the enemy. Step 7. Global famine and the death of agriculture. Now the question is, what would happen if crop production were to decline by 87%? Researcher Alan Robach explains, an 80% reduction in global crop production would have catastrophic consequences, leading to a massive global food crisis. Even a 7% reduction would have serious consequences for the global food system and economy, leading to increased food insecurity and hunger. The Penn State University team wrote in their study, a nuclear war would not only cause unimaginable loss of life and genetic resources, but would also create a prolonged nuclear winter that would reduce agricultural area and productivity for years. Corn is not just food. It is the world's most widely grown crop, a source of livestock feed, fuel, and the raw material for countless industrial products. This collapse in corn production is a reflection of the collapse of the entire agricultural system. It's not just cold and dark. The problem goes deeper. The lack of sunlight would stop photosynthesis, crops would die in the field, livestock will freeze to death, and those that survive will have no grass to eat. The phytoplankton in the ocean, which produces 50% of the world's oxygen, will die from lack of sunlight. As a result, the marine food chain will collapse and fish production will drop to almost zero. According to researchers, even a 7% deficit in global grain production is enough to cause a global food crisis and famine. An 87% deficit means there will be nothing left. The few people who are still alive in any part of the world will find themselves without a source of food. Supermarket shelves will be empty, warehouses will be empty, and fields will be covered in scorched earth and ice. Step 8. Radioactive fallout and global poisoning. The soil, rocks, and other materials vaporized during the first explosion will mix with the atmosphere to form radioactive particles. These particles will float in the air and spread throughout the world. These particles will fall to the ground in the form of rain, called radioactive fallout. A nuclear explosion produces more than 300 different isotopes, with half-lives ranging from fractions of a second to millions of years. The radioactive decay formula is N of T equals N0 times 1/2 to the power of TdE over T 1/2, where N of T is the number of nuclei remaining at time dt, N0 is the initial number, and T 1/2 is the half-life. In the first few hours after the explosion, the radioactivity level drops rapidly. It is only 10% of what it was 1 hour later, and 7 hours later, it is only 10%. But isotopes with long half-lives, such as cesium-137, 30 years, and strontium-90, 27.7 years, will continue to poison the environment for a long time. Plutonium-239 has a half-life of about 24,000 years, contaminating the environment for generations. The level of radioactivity would be so high that within months, perhaps years, large areas of the Earth would be completely uninhabitable. The groundwater would also be radioactive. There would be no sign of fish in rivers and lakes. No plants growing in the ground would be fit for eating. For comparison, an exclusion zone of 2,600 square kilometers after the Chernobyl nuclear accident is still uninhabitable. In a full-scale nuclear war, such a zone would cover millions of square kilometers. Step 9. The final outcome: the end of human civilization. According to scientists, the collapse of civilization is not only inevitable, it will be permanent. Nuclear winter could last more than a decade. It will take 15 years for the ozone layer to recover. But by then, the Earth's ecosystem will have reached a point from which it is almost impossible to return. The question arises, will anyone survive at all? Studies have shown that if all the world's nuclear weapons were detonated evenly over major cities, about 360 million people would die initially. And most of those who survive the initial explosion would die from subsequent famine, radiation, and epidemics. According to researcher Alan Robach, 5.3 billion people could die from subsequent famine in a full-scale nuclear war. Another tragic fact: the number of deaths from hunger in distant neutral countries would be 10 times higher than in countries directly affected by the war. Investigative journalist Annie Jacobson claims in her book Nuclear War: A Scenario that up to 5 billion people could die in the first 72 minutes of a nuclear war. There have been 5 mass extinctions in the history of the world. The last one wiped out the dinosaurs. Scientists say that if all the nuclear weapons in the world were to explode together, then humanity would be the first and main victim of the 6th mass extinction. 12,500 nuclear weapons, 1 moment, and the end of 12,000 years of human civilization. This story is not fantasy. It is science. It is reality. These weapons are still here, installed in silos, stored in submarines, ready on bombers. SIPRI's 2025 report says that almost all of the world's 9 nuclear powers are now modernizing their nuclear weapons. Russia and the United States still hold about 87% of the world's nuclear weapon stockpiles. Russia has about 5,460 warheads, and the United States has about 5,180 warheads. China's arsenal is growing the fastest, currently holding about 600 warheads and producing about 100 new warheads each year. France has 290, and the United Kingdom has 225 warheads. India has 180, and Pakistan has 170 warheads. North Korea and Israel also have nuclear weapons, although their exact numbers are unknown. Researchers warn that decades of nuclear disarmament are coming to an end. The threat of nuclear weapons around the world is growing again. The situation is becoming more complicated by the weakness of arms control systems, rapid technological development, and geopolitical tensions. So the next time you wonder, why all the fuss about nuclear bombs? Remember, not one of these 12,500 devices will bring good to humanity. They only know destruction. And once all of them wake up together, this planet called Earth will survive, but we will have no place on it. If you like the video, give it a like, and if you like watching such videos, subscribe to the channel and stay with us. And don't forget to share your important opinions in the comments. Thank you very much for watching the video completely.